My name is Yoshifumi Kitamura, and I'm going to talk about the AI and social robots for elderly. RIEC started the inter-organizational research project several years ago, and last year, this fiscal year, we just started the international type of inter-organizational research project. And we have this kind of research project, and we're going to present this project with Tohoku University and National Taiwan University. Originally, we had a plan to present this work by Professor Li-Chen and Su-Ling. But unfortunately, both of them are distinguished professors from the information science and information engineering and Department of Psychology, and both belong to the Center of Artificial Intelligence and Advanced Robotics. But unfortunately, both of them cannot come today. Instead, the Edwin Gambrino and Li-Chen and Chun-Ling Han, the research assistants, will present their part of the collaboration with the help of the robot. Okay, super aging society is coming. The global population aged 60 or over, or 80 or over, are both increasing rapidly, especially by 2030. Asia will be home to more than half, and in 2050, probably nearly 60% of the world's oldest old persons live in Asia. Of course, including me, because this is 30 years later. I guess most of you, including this group. The percentage aged 60 years old or older will become more than 30%, especially in Taiwan and Japan. According to the socio-emotional selectivity theory, the people with age become increasingly selective, investing greater resources in emotionally meaningful goals and activities. As a result, older adults feel lonely, and in spite of the fact that they are willing to share, but no listeners there. Therefore, the precious skills and knowledge may be lost. Maslow's hierarchy of needs is a famous theory in psychology, proposed by Abraham Maslow in 1940s. He used the term of sociological needs and safety and security, and love and belonging, self-esteem and self-actualization, to describe the pattern through which human motivations generally move and leads human growth. Here the goal of this theory is to attain the top or fifth or the level of stage self-actualization. One of the most important points here is, in order to get the motivation to occur at the next level, each level must be be satisfied. As explained, older adults feel lonely. They often face a condition in which the friendship or family are apt to be insufficient. Thus, the level of the love and belonging is not satisfied. This means that older adults lack purpose of their lives. Therefore, we came up with the idea of proposing inference, which is easy autobiography maker, because a retrospective view of his or her life and share it with others is helpful to fulfill his or her sense of satisfaction and higher order needs, that is, self-actualization. And it is designed to help individuals to create their personal autobiography with a friendly user interface and artificial intelligence. It is also expected to have a benefit to reserve wisdom and skills from retired professionals. Here, photos which represent his or her life, flexibly selected according to the context by artificial intelligence, are expected to be used to make the autobiography. This project will be explained by the researcher from the National Taiwan University later. Another serious problem in super-aging society is dementia, which is chiho in Japanese. Worldwide, around 50 million people have dementia, and there are nearly 10 million new cases every year. The estimated proportion of the general population age 60 or over with dementia is between 5 to 8 per 100 people. The total number of the people with dementia is projected to reach 82 in 2030 and 152 million in 2050. Therefore, dementia treatment is very important. And for this purpose, reminiscence therapy is becoming very common. With increasing number of people having dementia, robot therapists will soon be necessary. Which is the dementia therapist is now treated by the reminiscence therapy, which is the psychological intervention based on the evocation and discussion with therapists about past activities, events, and experience using variety of supporting materials like photographs. Photographs which are carefully selected according to the context of the evocation and the discussion with therapist or robot is necessary. This project will also be explained by the researcher from National Taiwan University later. This slide shows the framework of the presentation today. We are going to present two projects, which is iPlus, easy autobiography maker, and second one is a robot-assisted reminiscence therapy. For both cases, they need a set of photographs, which is carefully selected or sorted or grouped according to the context. For this purpose, DFlip, which is one of the achievements of my group in the Tohoku University, can be used. So this is the dynamic and flexible interactive photo show. I'm going to demonstrate this first before explaining this each project later. Yes, this is the image. This is the view of the DFlip. For example, so if each of the photographs are becoming larger, but it's not want to occlude each other. So they are pushing with the neighbor's photographs. And if I select one of them, it becomes larger. And neighboring photos will move to the outside and to make the space. And if I choose this one, for example, so this is the Canada photos. The other photo of the Canada, maybe you know this. So this is the photo of the Vancouver, comes along, follow this selection. And maybe this is Osaka. The Japanese photo taken in Japan will come like this. And I sorted maybe the shooting date. Assume this is the picture. Someone go to the maybe world trip and take the photos. This is the database of his album. Maybe. And so this is sorted from the 1994 to 2017. This is, for example, from the left to right. The shooting, the photographs are sorted by the date. And for example, this is maybe the vertical axis, which shows the reminiscence, and probably you can understand the darker ones become the bottom, and the lighter ones go to the top. And of course, there is maybe saturation because the frame of the photos indicates this barrier, but it's difficult, so it's possible to see from the side like this. And out. And of course, so this the photograph goes to the place it's shot it like this. And if I draw the circle like this, for example, Japan, the photo go to the inside, and here maybe Taiwan go to the red, and maybe here Sendai photo goes to the blue one, but of course also included in the green one. This is the method of the arrangement system of the photographs according to the metadata very flexibly, interactively. So this technique can be used to the projects we are undergoing with the member of the National Taiwan University.
Hi, I'm Dongling Huang, and on behalf of Professor Su-Ling from National Taiwan University Psychology Department. And let me introduce our Project 1 iPad Easy Autobiography Maker. So what's iPad? iPad is a platform which helps you easily make your own stories by yourself. And we have two goals. The first one is to make autobiography easier. And the second one is to preserve our knowledge and skills at the same time. So why call iPad? I means me, and pad means road, but also we want to record the journey of your life. Also, interestingly, pad is a short version of psychology and autobiography or AI, technology and human-computer interaction. So which means that we combine these four domains to design this product. And we are developing four main functions, including these four ones. With these four main functions, we want to help elderly to achieve their sense of purpose in their life and achieve while aging and well-being. So, why are we gonna do this? So before we design this whole product, we do a product making procedure here. We first define users' need by an in-depth interview. And then right now we are doing our first prototype. After that, in future we're gonna test its usability and acceptance. Refine it and also check its validation in future. So let's talk about how we define our users' need. And we held an in-depth interview, and we asked our subject to tell a 3-minute narrative of their travel experience to train our database. And we have 20 subjects, and 75% of them are above their 60, and 25% of them are in their middle age. After that, we do a content analysis of our interview content. So here's our interview protocol. You can see the interview block here. We separate 4 topics and total has 10 items. And the first one is we ask the elderly's technology using habits, and also to ask them what's their perspective of storytelling. And interestingly, we ask them at their topic that imagine you want to digitalize your autobiography. Which helper would you choose, human or AI? And the last one is their opinions on this project design. So here's the concise content analysis result. On the left side of the slide I extract some example from the interview content. And the right side of the slide is some important features after we do the content analysis. So you can see that all the subjects want customized interface when they're using technology device. And also, when they're doing their autobiography, they hope that app or AI as their editor, because AI is non-judgmental, and it's more accurate and can be controlled by yourself. And most of them are willing to share their story and willing to listen to others' story. And half of them are mainly preserve their memories or stories by photos, maybe with some description. And 27% of them are preserve positive content when they share and listen stories. So what's users need right now? We know that the elderly's need is they want customized interface, and they prefer AI as an editor, and they are willing to share and willing to listen. Also, they want to visualize their story. So, due to these needs, we start to develop our first prototype. So here's the system architecture here. We separate it to 2 parts. The first part is image adjustment, and the second part is Professor Kitamura's deep system. And the first part, we build a website that the user can edit their photos and export to DeepLib with metadata. And user can voice control DeepLib system and visualize their story by image with some visual feedback. So they increase their motivation to use this product, and they encourage them to tell more about themselves. So, but why we choose DeepLib? Because back to our users' need. They actually want customized interface, and they also prefer AI as their editor when they're doing their autobiography, and they want to share and want to listen. Also, they want to visualize their story. So DeepLib can achieve all of them because it has an excellent display functions. So due to this, thanks to this display functions, it can induce human-computer interactive behavior by visualizing the stories with images. And it has a friendly interface that is suitable for a wide range of users' ages that needs customized user interface. So although our projects are still ongoing, but we hope that in the future we want the elderly can benefit from iPad through the retrospective view on his or her life and can acquire the resilience when they're aging and wisdom preservation and achieve while aging and well-being.
Hello, my name is Edwin, and I come in representation of Professor Li-Chen, and I will explain the second project, collaboration with Dr. Kitamura. So yeah, for robot-assisted reminiscence therapy. So for regular reminiscence therapy, the therapist will ask questions because from when we know the picture can only give us so much information. So the way that we can know more about what's in the memory of the user is by asking. Maybe they can tell us what happened, what time, who was there, this kind of question. However, so if we want to let a robot do this kind of interaction, so we replace a robot, the person for a robot, it is impossible for the robot to know the ground truth of the memory. That is, the robot can never know what's actually inside the mind of the user. So this is the first big challenge. Then, so as I said before, in a conversation, we can find topics to keep the discussion ongoing by associating related concepts. However, for a robot, it's also quite difficult because a robot doesn't have this kind of common sense knowledge that all of us acquire from our life experience. So how can we solve this issue? So, for example, if we see this picture of this lady maybe on her holiday on the seaside, a person may ask, maybe, so did you go with your friends? Or was the weather hot? Or maybe did you surf? However, you can see that none of these concepts are directly observed from the picture. This is because we know that these are activities or things related to going to the beach. So a robot may use some deep learning technique to try to extract some meaningful entity from this picture. For example, it may detect that there is a person, and it could even understand that this picture is in a sea holiday or in a beach. But this information is still insufficient for the robot to be able to ask similar questions. So in order to augment the ability of the robot to ask questions, we are proposing to use a extended knowledge base that will help the robot to ask this kind of questions. So more formally, we want to let the robot provide guidance in the process of reminiscence by asking proper and engaging questions about the photo. We want to achieve this by first, as I mentioned before, extracting relevant information from the user's personal album and through the interaction from their speech. Then the second is building the knowledge base that will let the robot have more concepts to generate new questions. And these questions should be able to help the user to retrieve their memory from the photo. So the interaction flow of this project is, at first, from the right-hand side, we can see that first we do image processing. So we have, for example, in this example, the image of a graduation. So the robot can extract this kind of, maybe some people and some event from this picture, then do a concept inference. So from this, this is a abstract of knowledge base called ConceptNet. So from these nodes that are got from the picture, we can get more information that can be used to ask questions that are not necessarily inside the picture. For example, in this case, the robot may ask, "What was your favorite class in university?" So yeah, this is the system architecture. So we can extract information for generating questions from verbal on the blue side, on the left-hand side, using the robot, and from the visual entities from the picture using the DeepLib UI on the right-hand side. And then use these entities in order to generate new concepts and ask the questions to the user. On the next slide, we will show a brief demo video of our progress on this project.
你好，可以多告诉我一点吗？这是我去年冬天去滑雪的照片。你会不会憧憬滑雪这项运动？感觉超级刺激，好玩的耶！会呀，我有跟朋友一起去玩，很刺激。我换照片了。 让我想一想，请等我一下，可以吗？可以。这是你去海边玩的照片吗？是，今年夏天跟朋友一起去海边玩。这个海边可以浮潜吗？可以。
Yeah, so as you could observe from the video, we can use the DeepLib system to pick the picture, to select the picture that we want to talk about with the robot, and the robot will, on real time, generate questions in order to let us remember what happened on this day. So, what is the advantage, or why do we want to use a robot? Maybe you may think that a robot is not necessary. We can just use a chatbot or something inside a computer. Why do we need a robot? So the reasons are, like, first, the agent that has the physical body will give it increased agency over the user. So in this case, agency refers to the ability of the robot to, like, influence our decisions or our thinking. The second one is that the user are more likely to create social bonds with a robot or with something physical than with a virtual agent. And lastly, the robot will have a higher level, or user will feel more curious about the robot, so maybe they're more likely to play with the system in the first place if it is a robot compared to a computer. Finally, how about why do we need to use DeepLib? Why not just use a static picture? So this, basically the main reason is that if we can have this highly dynamic environment where we can show several pictures at the same time, this may increase the impact of that the user can remember by seeing many pictures at the same time. And the robot can also have more information in order to have a more fluent and consistent interaction with the user. Finally, for our future goals, we want to improve the accuracy of this system and determine more semantic bond between pictures and utilize this relationship between picture and picture to make a more fluent interaction, and do some clinical trials to determine whether this actually can help elderly users to retrieve their memories and slow down brain deterioration.
Okay. So today we presented two projects, but these are very early stage of our collaboration. In the framework of the collaboration, international inter-organization research projects with National Taiwan University. We had many projects, but today we just 2 of these projects were presented. But as you can see, many professors are participating in this project. This is the snapshot of the first symposium in the National Taiwan University. We had an oral presentation, the panel discussion, and so on. The second one was held last year in here in RIEC, Tohoku University. And if you are interested in this project, please join us. And the PI of this project in Tohoku University is Shioiri Sensei, so please contact him or me. Thank you very much.
Thank you very much.